Hey, this is Dave Consumer. So I just want to show off very quickly some new stuff I've been doing around plugins. There's a lot of different kind of plugins and units like that are just built in. And so I just wanted to talk quickly again about how cool plugins are and how there's other stuff on here. So here we're starting with a Scratch setup, right? And um, well, let's start with like just. I think this one's pretty cool. So this is built in. This actually isn't a plugin. It's one of the built-in units. It's called Chopper. So first, I'm going to build a simple drum kit. Right. This is the standard SF2 general MIDI drum kit, and I'm going to just load. I don't know. I'm going to load some pre-made beat in here. Probably. Let's try Bhutan. All right, sounds pretty good. So here's what Chopper does. So Chopper gives you a way to the beat, because all of these are parameters. You can use a delay that has no feedback. So it just chops over things that it's already heard. And this is good for like throwing in like break accents and things like that. But here, let's listen to what it sounds like. And there's two modes here. There's line and beat. And so line, this number means like how many lines. So for example, if I do 4, this is like 4 lines in the pattern here. So it's basically like a sharper granularity than beat, which is basically it takes the beats per minute and uses like division of that, assuming that every line is a 16th. So anyway, using those two kinds of things, you can create like different sort of effects. But check this out. So yeah, the idea here is that it's kind of like a granular synth or like a delay, but it's made more for like doing accents on beats. And you'll see this in other things like the KO2 I think has like some kind of chopper repeater thing. Renoise has a really good repeater, and this is kind of based on the one on Renoise. Like in terms of functionality, like I looked at that to try and figure out how it should work. You can also do interesting stuff with this. So you can get like polyrhythms. And you can also like free is just kind of whatever you want, but it's still within this like weird range. So it's not really whatever you want because the controller can only do like these big jumps, but it kind of is. So here's an example of free. It's totally weird. But yeah, the idea is there is like you can modify your beats on the fly, and you can do like little accents. All right, so that's Chopper. And then another one. This one doesn't look like much at first. So this is a plugin, and I started working on being able to make like in puredata. I love puredata. And in puredata, you can build like patches that do something, like create sound or create effects or whatever you want. And so the way these patches work is they have like audio inlet and audio outlet, which is like ADC and DAC, which is like the standard in puredata for like mics and speakers, right? And then note in is like MIDI note in, and those three things can be tied to the host here, which is pokedata, right? Or sorry, poketracker. And so because it can be tied to it, poketracker can send, when it sends those notes, it sends it through the note in. So you can do whatever you want with that in your own patch. Here, I'll actually show an example of what this is. So if we go here, and let's look at this super saw. I'll sort of tear it down for a bit. So I use plug data, which is like a fork of pure data. It just has a nicer UI, and I think it's better. But it basically works exactly the same, and the file formats are the same. It just looks nicer, and I don't know, it works a little better for me. This is also cross-platform, so it works on Mac, Linux, and Windows. But if you look at this, this is the super saw, and so the idea is I've got a detune here, and I've got a note in, and it doesn't take any analog audio. It just takes the note in, and then it routes it to each one of these voices. Now this is a polyphonic pattern here, where basically like I give it 4 voices and I split the incoming notes between the 4 things, and it tracks like when should it do note off and on and all that. It even does this last parameter 1 here is voice stealing, which means when it runs out of channels, like because it only has 4 channels in this setup. You can do as many as you want though, but here I have 4. So when it runs out of channels, it will turn off the first one. So it's like a FIFO buffer, first in, first out, or whatever. Okay, and so if we look at one of these individual voices, this is a whole. This is all by itself. It's a supersaw. So it's got 7 different phasers, which are their saw wave oscillators. And I do some math here to like to sum them together so they sound better, so they don't so it doesn't end up too loud and clip and all that. And then I also do some math around detuning to like get the detuning to work smoothly and seem good. There's a couple other things too, like it's taking this note message and it actually does like a V line, which is a smooth volume envelope, right? So when the note comes in, it slides up, and then when the note goes out, it slides down in terms of volume. And this gives it like just a rounder, more analog feel. It sounds more like the way capacitors sound or whatever, but totally optional. This one is like maybe a little overly fancy, but that's the idea. So anyway, so basically the note comes in, it gets routed into 4 different voices. Each one of these is all the same as the first one that I showed you. These get divided by 4 in terms of audio, which I'm doing that because I want, like when these come out, they're basically full volume. So I want them to be divided by 4 because I have 4 voices. And that means that if you do like like 4 sounds all at once, like an accord or something, then it won't like sound crazy loud. It'll sound okay. And another reason why I do that is because if you get the volume like a little bit lower, you can always put a compressor on it after, and it'll raise everything to the right volume and keep it like uniform. But if it's like too loud, then it just clips and you just hit the edge of like what the audio engine can do. And so anyway, all that stuff, you probably don't even need to worry about that stuff in general. I'll show you a much simpler one. So if we look at this, hold on. If we look at like this, this VCF is stupid simple. So if we look at this VCF, it doesn't take any incoming. It basically just outputs noise that goes through a filter, and then there's a cutoff. Another thing to note about these is that the way the parameters work, if you're in edit mode and you click on this thing, it has a receive for detune, for the message name detune, which when the patch like converts this into a proper plugin, it sees that and it sees, oh, you're not sending anything to detune, so that must be an input, and so it'll use that as an input parameter, which is really handy. In general, I try and use controls like this instead of just a receive, because you could just do a R detune and it would receive the note, but it doesn't have any information about the scale, and so I had to just guess, which is like 0 to 1 is my guess. But with this, you can scale it to whatever you want. So I have a scale of 0 to 255, and the reason I do that is because that happens to be the scale in poketrack that it can do a parameter value, which is like 0 to FF, right? So FF is 255. So anyway, it's a lot of math, but the reason I do that is because I wanted this one to be like a really solid, like realistic example of like how you might do it if you were going to like make a proper plugin. Some of the other ones are really simple, like the VCF. You can see how that's super simple, and it works the same way. So if you look at this cutoff, you can see it receives a cutoff message here, and then it's got 100 and 5,000, and so that sets the range. And so 0 will be 100, and FF will be 5,000, and it'll just figure out the range from there. Now, one thing to keep in mind with that is that whenever you don't do 0 to 255 or something to 255, you're going to get like integer, math that it's, or like float math where it's like kind of rounding to whatever the closest one for that like cutoff is. So I like to do all the math for getting that to look good inside pure data. So a lot of times I'll just make my inputs like 0 to 127, which is MIDI. I do that for a lot of like just standard patches that I use and things. But in poketrack, you might want to consider 0 to 255 because that's the actual granularity of like a real message that comes in. You won't get any messages that are, more granular than that. Like you can set the range to 0 to 1, but it's still just 1 split into 255, pieces, right? Okay, so anyway, so we got this super saw, cool, and it's got a detune, it's got a note in, and it's got a DAC, which normally this would be like the volume, and I don't have like a MIDI keyboard attached here, but I could actually just test this directly with a MIDI keyboard and it would work. This is a totally standard patch, nothing's weird about it. This is just a pure data thing. Now, another note about making stuff in pure data is that there is this compile mode. Compile doesn't actually work for poketrack. It's like a totally different thing. It does something else. But compile mode, what it means is like use a small subset of pure data. Don't use anything fancy. Don't use any extensions, like native extensions. Don't use any like weird stuff. So it might help you to stay in compile mode. It's kind of like pure data vanilla with no extensions. And that's pretty much the version of pure data that poketracker is going to like be able to understand. On conversion, so I have like a whole other project for converting pure data and stuff. And if people want more info, I could turn it into like a web app or something, so it's accessible and you don't need to install any tools. But essentially, you compile your pure data patch into a very efficient WASM code, and that WASM code can be shared with anybody, and they don't need to recompile it. So when these are compiled, if you look in the examples, these plugins, that's where these PD ones came from. This is that VCF one, and this is the Supersaw. And these things are completely self-contained, and they work on the web or on any native or anything, doesn't matter. And then I wrote other ones too. So like RoboTalk was written in assembly script, which is kind of like TypeScript or JavaScript. It's a very simple language, but it actually produces like pretty efficient WASM. And then Carp was made I think it was made in Rust. I made it a while ago, but and this is like a string simulator, and it's incredibly fancy, but it works just like if you were making like a native clap plugin. It all works just like that. I just target WASM, so it's so you can use it anywhere. Okay, so now that we've got this, let's go here and let's try out our Supersaw. So like I said, it's not that fancy when you first look at it, but you'll notice that detune, which is that one receive parameter that it gets, the GUI element that was at the top, is in here, and it goes, it always goes 0 to FF, but it will split it to whatever the range is for that element. So for that element, I use 0 to FF just so it's very clear, like it's the same numbers, and then I can do all the math inside the pure data patch, and it's easier. Okay, so this is not that fancy, but so when you listen to it, you're just like, oh, well, that's just like a saw. Who cares? Now, one other thing to note is that you'll notice that it just kind of holds the note. This is something that you're going to have to think about if you do pure data. Normally, if you use like an oscillator inside a poketrack, it has its own like envelope. And I did that because I didn't want things to like just play forever, So in pure data, though, I just give users the control of absolutely everything. Like I'll give you the note messages and you just do whatever you're going to do with that. And so I have a pretty simple line in there that listens for note off messages. That's kind of the normal way to do it for like a MIDI keyboard in Pure Data. But the tracker paradigm is basically like cut off when you hit another note and not before that. So one way you can get around that is you can hold A and B at the same time, and it'll do a cut. And so this cut will send a note off stop message, so it stops. So that makes it sound a little better. Each one of these notes is stopping the one before it, and then it's sending that one. So, okay, so this isn't that exciting, but check this out. Now, one thing to note here too is that there's a million ways to accomplish the same goal. If you play around with an oscillator plus a phaser or maybe a flanger, you could probably get a very similar sound. Or like chorus also is kind of similar. So the idea with the supersaw is that it plays a massive amount of waveforms, and they're all off by like a little bit frequency wise. And so it plays them all at the same time, but they're all a little bit off. And that's what detune is like how much is it off. So if you think about chorus does kind of the same thing, where it just records a tiny bit in a delay buffer, and then it plays all the delay buffers at different speeds, and the distance between those, like at the speeds of each one, is what gives you the feel of like a chorus of voices or whatever. Or like a chorus of guitars playing all at the same time. So keep that in mind. You might be able to play around with other things. The reason I say it's not just a chorus is that supersaw, it's all to the phase of the actual instruments, and so they're offset as if it's like a real analog instrument. Whereas if you look at chorus, it's offset by like whatever the delay buffer is, so it doesn't sound exactly the same. But maybe doing something with a flanger, you could kind of give the vibe of that like that period sound where it's like, it's going to like a sine wave overall. Anyway, it's just something to think about. You can achieve the same kind of sound like a million different ways. You could also probably use a sound font to do the same thing, with a very tiny sample of like a waveform, and it's offset a little bit. You could also probably make a bunch of notes that are like, microtonally offset or something like that. I don't know, man. But anyway, keep that in mind. There's a lot of different ways to do it. This is a fairly cheap way, but the point isn't necessarily the supersaw. It's more that I made the whole thing in Pure Data. So you can just make any crazy idea that you have for like a sound generator or some kind of weird effect. You can prototype it in Pure Data, play around with it until you get it working the way you want, and then compile it, and you have like a ready-made plugin that's ready to go. This plugin is way more efficient than Pure Data as well, so it runs on like lower end devices, it runs on the web, it runs all over. So anyway, something to keep in mind. It's kind of a way to like hard code like what weird stuff you came up with in Pure Data. There are definitely some limitations though. I think Metro works a little bit different, and that's a really basic thing in Pure Data. Like you use that for everything. So you might have to like rework your plugins a little bit, or rework your Pure Data patches to get them to work. But overall, that's the general idea. I guess that's it. Have fun.